Let's continue to discuss about handling workshop tools and power tools. At the end of this session, you will be able to understand tightening and locking devices, learn to make flare joints and fittings.
Tools and instruments required: internal and external circlip pliers, combination pliers, tube cutter, flaring toolkit, adjustable wrench, pressure gauge unit. Materials required: slotted nuts as required, bolts and hole as required, split pin as required, circlip as required, wire ring clamp as required, hose as required, copper brass tube as required, thread steel tape as required, flare nut as required, cotton waste as required. Now let's know about the tightening of locking devices. Let us take a bolt with a hole and a nut with slot to lock. First, tighten the nut at the specified torque. Do not over-tight the nut. Now, check the bolt's hole and the nut's hole alignment. Both the holes should be seen through and aligned properly. If not aligned, align the hole by tightening the nut slightly. Take a split pin and insert the pin in the slot and hole so that the loop on vertical plane. Using copper drift or hammer, drive the split pin fully inside the nut. Now, using a plier, spread open the long side of the split pin and bend it on the nut. Locking inside a circlip or snap ring. Perform this job, we will use the internal circlip. It is used to fit and remove the internal circlip in a groove of the bore. Use an internal circlip plier to hold the circlip on hole face. Press the circlip with the plier so that the diameter of the circlip becomes smaller than the hole diameter. Insert the circlip and make sure that the clip sits squarely in the groove. Make sure the circlip is placed properly by rotating it. Take out the plier after rotation.
Locking outside circlip or snap ring.
Hold a outside circlip shaft end with the help of an external circlip plier. Press the external circlip plier so that the circlip will enlarge the diameter. Now slide the circlip and set it the shaft groove. Ensure that the circlip sits properly on the groove, rotates freely. Now take out the plier. Locking wire ring clamp. To perform this job, we will use combination plier.
Clean the outside surface where the hose pipe is to be set.
Apply grease inside the starting end surface for easy insertion. Now let's know how to handle pipe flaring and cutting tools. A pipe cutter is more convenient and better than a saw when cutting pipes and metal tubes. The sharpened wheel in the cutter does the cutting. As the tool turns around the pipe, the screw increases the pressure, driving the wheel deeper and deeper through the pipe until it finally cuts right through. Now we will see how we can cut a GI pipe or galvanized iron pipe using a pipe cutter. Take a GI pipe of required length. Mark it with chalk where we need to cut. Hold the pipe in the pipe vise and tighten it. Fix the pipe cutter on the GI pipe and tighten the jack screw so that the cutting wheel touches the pipe. Rotate the cutter 1 or 2 times on the mark to ensure the cutting wheel is sitting exactly on the marked line at 90 degree. Now turn the jack screw to put pressure on the cutting wheel and keep rotating the cutter. Keep pressuring the cutting wheel and rotate till the pipe is cut through. Hold the pipe so that the pipe won't fall once it gets cut. Check the pipe ends are in shape once it is done. Now let's know how to make flare joints and test them with the flare fittings. When connecting tubes to fittings, it is common practice to flare the end of the tube and to use fittings designed to grip the flare for a vapor tight seal. Special tools are used for making flares. There are two types of flaring: single thickness flare, double thickness flare. Widening one end of pipe gradually is known as flaring. For example, we can see this kind of pipe in brake line pipes, fuel pipe lines, air conditioner pipe, etc. Before flaring, examine the pipe flaring tool. Make sure that you understand how it works before starting to flare the end of a pipe. Make sure that the end of the pipe is free or rough edges from flaring. Now, place the flare nut on the pipe. Choose the correct size hole in the flaring tool to fit the pipe. Tighten the nut at each end of the flaring block. Oil the cone and slowly screw it onto the end of the pipe. Now a flare will be formed at the end of the pipe. Unscrew and remove the flaring block and flared pipe from the block. Check the flare for any crack. Make sure that the flare is in the correct size. It should just fit inside the flare nut. If it is too loose, then repeat it again to make a new flare. We can take an example to calculate the flare. There are 5 holes to fit different size of pipe. If the pipe is 1 by 4 inch, that is 6 mm in diameter, position the pipe so that the end is at least 2 millimeters above the top of the flaring block. This distance is calculated as pipe diameter divided by 3. In this case, 6 mm divided by 3 is equal to 2 mm. Now let's learn joining the flare fittings. Put thread seal tape on the thread. Push back the flare nut and place the flared tube on the fitting. Tighten the flare nut using an adjustable wrench or suitable double end spanner. Do not over tight the nut. Flare may crack or get cut. Tighten one end of the tube to the cylinder with the flare nut. Connect the pressure gauge at the other end of the tube with the flare nut. Check for any leakage. Use soap solution to check if there are any bubbles. If there is no leak, the pressure in the pressure gauge remains the same, else it will decrease. Then you need to tighten the nut.
Let us summarize this session on handling workshop tools and power tools. Understand various topics like tightening and locking devices, making flare joints and fittings, handling pipe flaring and cutting tools, and joining with flare fittings. Use of specific tools like internal and external circlip layers, pipe cutter, and flare nut wrench for proper handling and maintenance. Understood that flaring is a process of widening one end of a pipe to create a secure connection with the flare fitting for a vapor tight seal.